Hello students, welcome back to my class. Once again, same topic will be continued. As you know, this is my video number 9. Please share, like, comment and subscribe my channel. Again, same topic with PUC second year mathematics, continuity and differentiability. Today in this video I will discuss two problems and then we will stop, then we will discuss differentiation. But let this be the last video on continuity. Okay. Now here is a question, next question. Find the value of A and B such that the function defined by f of x is equal to 5 if x is less than or equal to 2, and f of x is equal to ax plus b if x lies between 2 and 10, and f of x is equal to 21 if x is greater than or equal to 10. This is the function, and it is continuous function. It is continuous everywhere. It is continuous means it is continuous everywhere for all values of x. Now, see what we have to do. We have to find the value of a and b. And clearly, f of x for x less than or equal to 2 and less than 2, f of x is equal to 5. And between 2 and 10, f of x is equal to ax plus b, and at x is equal to 10 at 10, and on the right of 10, f of x is equal to 21. Right? This is a defined function. This is how it is defined. Now we have to find the value of a and b. We'll do the same thing. We'll find it is given that f of 2 is given. F of 2 at x is equal to 2, the value of function is 5. It is given, right? At x is equal to 2, f of x is equal to 5. And on the left of 2 also it is. Now we will find right hand limit. Now you may think that why we are finding right hand limit, why not left hand limit? Because on the left the function is clearly equal to 5. At 2 and left of 2 the function is equal to 5. So we will find right hand limit at x is equal to 2. For x is equal to 2, we are finding left hand limit. Sorry, we are finding right hand limit, right hand limit. So we are finding limit x approaches to 2 from right. Limit x approaches to 2 from right of f of x will be equal to limit x approaches to 2 from right, this is the function, right of 2, this is 2 is here, right of 2, f of x is equal to ax plus b, so we have to take this piece, ax plus b. We are not using left LHL and RHL formula, that's not important. We can do that without using formula also. We can directly apply the limit. Now one thing you have to be careful that on applying limit, this expression must not give the value 0 by 0. That will be undefined. If 0 by 0 is coming, then we have to do some simplification and then apply the limit, substitute the value. This I have already discussed in previous video. Right, now apply the limit. On applying limit, it will not be 0 by 0. Of course, there is no denominator here, so there is no chance of being 0 by 0. If it becomes 0, no problem. 0 by any other number, no problem. But 0 by 0 must not come. Okay, so apply. We replace x by 2. Apply the limit. So no need to write the limit. When you apply the limit, no need to write this because we are applying. So it becomes a into x is 2 plus b. So that becomes 2a plus b. We got RHL 2a plus b at x is equal to 2, the given function is equal to 5, and at x is equal to 5, as x approaches to 2 from right, it is equal to 2a plus b. So now RHL f of 2 must be equal to RHL according to the condition of continuity. We have already discussed LHL must be equal to RHL must be equal to f of a. This I have showed you. LHL must be equal to RHL must be equal to f of a. We have discussed this point in previous videos, right? Here RHL must be equal to f of a. RHL must be equal to f of a is here 2. We are finding limit at 2 now. Okay, so that becomes f of 2 is 5 is equal to RHL. We got RHL 2a plus b. 2a plus b is RHL, right? So we got one equation in a and b. We got an equation that is 2a plus b is equal to 5. This is equation number 1. Imagine this is equation number 1. Now let's do the same thing at x is equal to 10. We did this at x is equal to 2. Now what about f of 10? What is f of 10? What is the value of the function at x is equal to 10? It is 21. So f of 10 is 21. Clearly it is given in the question at x is equal to 10. F of x is 21. So f of 10 is 21. Now let's find the limit. Now what? Should we find RHL in this case or LHL? Like we found here RHL. In this case, should we find RHL or LHL this time? We have to find LHL again because RHL on the right of 10, the value is always 21. So we will find LHL. Okay, so now we are going to find LHL. As x approaches to 10, we are finding left hand limit as x approaches to 10. We are going to find limit x approaches to 10 from left of 10. So that will be equal of the f of x will be equal to limit x approaches to 10 from left. X approaches to 10 from left. What is the function? Again it is ax plus b on the left of 10. See, on the left of 10 we have f of x ax plus b. On the left of 10 it is ax plus b. So that becomes equal to, again replace x by 10. This minus is not minus 10. This minus indicates x approaches to 10 from left. Plus sign represents x approaches to 2 from right hand limit. Here this minus means left hand limit. Okay. So now if we substitute 10 here in place of x, it's not going to give us 0 by 0. So we can substitute. It becomes a into 10 plus b. That becomes equal to 10a plus b. We got LHL. Now we know from the definition of continuity, from the condition of continuity, LHL must be equal to f of a, RHL must be equal to f of a. So if LHL must be equal to f of 10 must be equal to f of a, here this time a is 10, must be equal to LHL. Now 10, what is f of 10? F of 10 is 21 is equal to what we got LHL. LHL is 10a plus b. So we got one more equation in terms of a and b. What is that equation? 10a plus b is equal to 21. This is equation number 2. We have two equations now in a and b. These are, you remember, you have already studied in 9th standard, 10th standard, simultaneous linear equations in two variables, right? You know how to solve them, right? Now subtract 1 from 2. Subtract equation number 1 from 2. So that gives us, so that will be equal to subtract 1 from 2. 10a plus b is equal to 21. Then subtract this, 2a plus b is equal to 5. We are subtracting 1 from 2. So since we are subtracting, so we have to change the sign. This plus will become minus, this plus will become minus, this plus will become minus, right? So this 10a minus 2a will be 8a, b minus b will get cancelled, b minus b will get cancelled. That will be equal to 21 minus 5 is 16. So a is equal to 16 over 8. 16 over 8 is 2, right? 8 to the 16. Then we got the value of A. A is 2. We got A 2. We can find B now. Take any one equation. Take any one equation. Let's take this one. 2A plus B is equal to 5. 2A plus B is equal to 5. Substitute the value of A here. So 2 into 2 plus B is equal to 5. Because A is 2, we have already found. So that's 4 plus B is equal to 5. That's B is equal to 5 minus 4. That is equal to 1. We got B equal to 1. So we got the values of A and B. We got A as well as B. This is how we solve this question. I hope you understand, and I want you to note down the solution and also practice. Watch each video many times and practice the problems. You will be good at this. Let's solve one more problem. Here is the next problem. The problem is find the value of k. We have to find the value of k. There is a constant k in the question. So that the function f defined as, this is the function, defined function, f of x is equal to kx plus 1 if x is less than or equal to 5, and f of x is equal to 3x minus 5 if x is greater than 5. Right? Again, a piecewise function is there. Is continuous at x is equal to 5, and it is given that the given function is continuous at x is equal to 5. We have to find it. See, here I have already drawn number line. At 5 and less than 5, the given function is kx plus 1, and greater than 5, for the values of x greater than 5 on the right of 5, f of x is equal to 3x minus 5. This is one function, this is another, this is one piece, this is another piece. Right, now we have to find. Now let's find LHL and RHL, right? Let's find LHL first. We are going to find LHL. So we are going to find limit x approaches to 5 from left of the given function, and that will be equal to limit x approaches to 5 from left, the give 5 from left, on the left of 5. Which piece should we take? This or this? Of course, this one, right? Kx plus 1, less than 5. These are the values less than 5. Left of 5, right? We are finding left hand limit, left of 5. So that will be kx plus 1. Now, replace x by 5 here and check if it is giving 0 by 0. Of course not. We do not have a denominator. So there is no chance of it becoming 0 by 0, right? So that will be k into 5 plus 1. So that will be equal to 5k plus 1. We replaced x by 5. Right? 5k plus 1. So we got LHL. What is LHL? 5k plus 1. Now let's find RHL. Let's find RHL. RHL will be, let's find RHL. We are going to find limit x approaches to 5 from right of the given function f of x, right? So that will be equal to limit x approaches to 5 from right, 5 from right, on the right of 5. What is the function? F of x is equal to 3x minus 5, right? So that will be 3x minus 5. This is the function, right? 3x minus 5. Because on the right of 5 we have 3x minus 5, x greater than 5 on the right of 5, right? Now, again apply the limit. So that will be replace x by 5. So that will be 3 into 5 is 10 minus 5. That will be equal to 15 minus 5. So that will be equal to 10. So we got LHL 5k plus 1 and RHL 10. Now, question says that this function is continuous at x is equal to 5. If it is continuous at x is equal to 5, then LHL must be equal to RHL, right? This is the condition of continuity. So LHL must be equal to RHL. LHL must be equal to RHL. So LHL, what is LHL? LHL is 5k plus 1. 5k plus 1 is equal to RHL. What is RHL? RHL is 10. Now we can solve this to get the value of k, right? It's a simple linear equation in one variable, right? It's a simple linear equation in one variable only, k. So that's 5k is equal to 10 minus 1 is 9. Therefore k is equal to 9 over 5. 9 by 5. We got the value of k. This is how we solve the problem, right? Practice each problem many times. You will be good at this. In the next video, I'm going to discuss differentiation. That is a very important topic again in calculus, right? Calculus comes for nearly 45 marks in exam. That's why I'm discussing calculus more in these videos. Thank you.